Cool. So I've been given the thumbs up that we're supposed to start. And hopefully you've seen the screen. It's Monitoring 101 with Postgres. So welcome, everyone. A little bit about me before I start. Who am I? Why should I be here talking to you about monitoring? I'm Jason. I work at a company called Datadog. If you're on Twitter, I'm GetBisect. But at Datadog, I'm a technical writer and evangelist, which means that I work with our engineers and I read through our code to figure out what it does, and then I write documentation to make that easier for developers and other engineers to use. I'm also an evangelist, so a large part of my job is exactly what I'm doing now. I come and talk to technical people about technical issues, sometimes about monitoring, but a wide range of issues. And I like to boil that down that I do docs and talks. A little bit about me personally. I'm a travel hacker, so I travel a lot. Sometimes I get on planes and fly nowhere in particular, just for miles. If you're interested in traveling, I'd love to talk with you about that later. Also a whiskey hunter. I really like whiskey. So if you know of any great whiskey places here in San Francisco, I'm always open for recommendations. A little bit about Datadog. Datadog is a SaaS-based monitoring platform. So you install our agent, or we connect with your cloud provider, pull all the metrics into our system, provide you with dashboards and alerting and monitoring. To give you an idea of the scale of what we handle, we do trillions of data points every day with thousands of customers. So tons and tons of data. And we are hiring. So I don't know if it's visible in the back of the room, but down at the bottom there, jobs.datadoghq.com. So if you're looking for an interesting job, solving really complex challenges around distributed systems and how you monitor them, we are hiring all across the stack. So we do a lot of monitoring. Unfortunately, when I talk to people, a lot of times this is their solution of monitoring, right? I think we all know people that do this. I've talked to plenty of people here at Postgres Open that are like, ask them, what are you doing for monitoring? And they're like, we're really not. And that's a bad thing. Not because I want you to buy Datadog. Like, you can do your own monitoring, especially if you're on a small scale. There's plenty of great open source tools out there. But because not having monitoring can be very, very expensive. So at Datadog, we like to say that collecting data is cheap, but not having it when you need it can be very expensive. To underscore that, a research group called the Aberdeen Group did a survey. They roughly placed the loss for a small company at about $8,000 per hour, right, for a small company. If you move up to a medium-sized company, the average revenue lost for an hour of downtime is $215,000. And if you move up to large companies, that number explodes up to about $700,000. So having downtime because you're not getting the proper insight and visibility on your systems can be extremely expensive. I did mention that I'm a travel hacker, so I really, really like looking at the airline industry. Is anyone here familiar with the BA outage that happened in May? Some people looks like they are. This first image on the left really explains all that you need to know about it. Complete meltdown. They didn't have any screens in the airport that would work anymore, so they actually brought out whiteboards and were just writing things analog on whiteboards, and that's how they let people know what was going on. But I throw these numbers at you of the average revenue loss for an hour of downtime, and a lot of times we think of things like that when you have an outage. How much time am I losing? How much is it costing me to have my engineers not work on what they're working on and go fix things? But a lot of times the things that we miss out on are things like, if our companies are large enough and they're public, having things like the loss of investor confidence. So BA actually lost 5% in their stock price due to the outage. If you multiply the actual loss number times the number of shares, it's somewhere around $80 trillion of loss, which is massive. And some people are like, that's fake money, it's just stocks. If you actually look at their real loss, the EU has really strict rules about what flyers and passengers are entitled to. So in real money losses, they actually had to pay out $72 million to passengers for that outage. So it's pretty clear that having outages because you're not monitoring can be extremely expensive. So you know that you need to be monitoring. What should you be monitoring, or how should you think of that monitoring? I like to tell people that there are 4 really good qualities of metrics. You shouldn't just be collecting any old metric. You need to think about what metrics are and how to conceptualize them. The first quality of good metrics really is that they have to be well understood. So if I understand a metric, I'm looking at a dashboard, I know what's going on, and you're on my team and you don't know what these numbers mean, then that's not a good metric, right? It's not useful information to you if you don't know what it means. A good example of this, actually, is the Mars orbiter. So in 1990, NASA was working with Lockheed Martin to build the Mars orbiter. The idea was they'd send up this satellite to orbit around Mars, take photos of the surface, learn a lot about the planet. NASA, being very scientifically minded, uses metric numbers, kilometers, kilograms, things that actual scientists use. But here in America, Lockheed Martin, American company, we use imperial numbers. And so they use miles, pounds, feet. Everyone thought they were on the same page with these numbers. And they clearly weren't when they were calculating the trajectories. So the Mars orbiter essentially was that. It crashed into Mars. Very big loss. The second good quality of metrics that you really need, aside from being well understood, is that they have to be sufficiently granular. So last year we had the Olympics. One of my favorite events is the men's 50-meter freestyle. It's a very fast event. These are some of the numbers from the medal race. And we can see that pretty much everybody completed the race in 21 seconds, except for Lithuania in 22 seconds. We understand that whole seconds cannot be our granularity for this. Like, it's fast enough event that we do it in hundredths of a second. And even at that, there is actually a tie there for sixth. So Brazil and South Africa both came in 21 seconds and 79 100ths of a second. And the same thing happens with your metrics. You need to have sufficient granularity when you're collecting your metrics. So what does that look like? Well, a lot of the metric systems that people are building don't do full second granularity. They roll things up into 1 minute or even 5 minutes. And so that's what it looks like. On the top, we have a chart that's showing CPU usage, and it's spiking at 46%. And that's at 1 second granularity. If we start to look at this on a 1 minute granularity, not only has that spike shifted forward to the start of the minute, so we're getting an inaccurate sense of when this happened, but it's getting averaged out, so it's only 36%. So now our CPU spike isn't quite as high. If you're doing this on a 5 minute aggregate, then not only are you, again, shifting that time to the beginning of a 5 minute period, but the peak is now 12%. So you can imagine that if you're looking at cloud providers or you're looking at rolling up your metrics into buckets of things like 1 minute, well, that may not be the granularity that you need. You might be saving space, you might be saving network bandwidth by compiling everything, but in the end, if you're not getting that accurate information that you need, then your metrics aren't really useful. The third quality of good metrics that you really need is that they have to be tagged and filterable. We're all building very complex systems these days with Postgres spread across a number of servers, using different applications with them. So understanding where your metrics are coming from by tagging them, adding that metadata in, makes them much more useful. One way that we like to think of it is essentially turning your metrics and your monitoring system into a database itself. So rather than just monitoring for CPU, you can now query when you have tags available, tags like what geography it's in, availability zone or region, what application it's part of, and what kind of server it's on. So you can do things like query against it to say, what's my CPU or what's my disk use on an Amazon AWS M3 large that's running in US East 1D that's part of my web application. So you can start to get more refined with what you're getting out of your metrics by having those tags and making them filterable. And then the final quality, the 4 good qualities of metrics that you need, is they need to be long-lived. A lot of people think their metrics are just to let them know what's happening right now. But without keeping your metrics around, you're not able to see the patterns and see the trends. And those can be extremely useful when you're actually analyzing your systems. A great use for that is actually to create anomaly detection. And it's pretty washed out on this screen, but there are some light gray bands around this chart. And that's our anomaly detection system figuring out where the metrics ought to be. Without seeing those gray bands, the people in the back that may not be able to see that, this probably just looks like a random up and down, like totally random graph. If you were to come up front and see some of those gray bandings, what you'd see is that there are 4 actual sections there. Well, it's 4 actual sections, and each 4 actual section has essentially 5 little spikes in it. Anomaly detection with that gray banding starts to point that out. And you can make sense of this and think, okay, what's got 5 things in it with valleys in between? Days of the week. So each of these groups, each of these 4 groups is a week. And each of those spikes is what happens on a daily basis. And then the anomaly detection system can look back at how the metric performed and note that, for example, the red that comes up in this second group, well, that dipped a little lower. What happened? Why didn't we have a spike on Monday the way that we normally predict? So you can use your past history to start seeing these trends and evaluating things when they don't perform as they have in the past. So that's the 4 qualities of metrics that you really need. Let's think about how we should use our metrics. And one way that we can think about that is really to group things into 2 types of metrics: work metrics and resource metrics. And then thinking of events as sort of a correlating factor. So when we talk about work metrics are really your high-level overview of your metrics. They're the things that matter to your business. So I particularly love donuts. I'll use the example of a donut factory. If I have a donut factory, my work metrics are things like, how many donuts am I producing every hour? Are my donuts properly glazed? Can I sell them? Or are they faulty and I have to throw them away? So thinking of the overall performance. Resource metrics, on the other hand, are the things that support your work metrics. Resource metrics for a donut factory would be things like, how much flour and sugar am I using at any given point? Do I have enough of overhead or enough in spare to produce more donuts if I need to? If we're thinking about systems, this is things like CPU, disk I/O, memory, things that people traditionally monitor, but may not be actually useful to the overall business of the company. And then events. Events are things that we correlate to find out what happens when something changes or something doesn't go the way that we thought. Events in the tech world or in your systems would be things like code changes, code deploys, configurations. Did someone push a new configuration with Ansible and now Postgres has less memory and so things are spiking? Or if you're thinking of donuts, National Donut Day. Why is everybody buying a donut today? So I mentioned about using your work metrics versus your resource metrics. And I think this tweet from Adrian Cole really expresses that well. A lot of people, if I were to ask you, looking at your metrics, is your company losing money? Is it making money? How are you serving your customers? I think a lot of people end up just monitoring those resources. How much CPU do I have? Without knowing how that fits into the general larger scheme of what your business is doing. And in short, what you ought to be doing is paging. All of your paging and alerting should be on those work metrics, the things that are important to your company. If your company is losing money, alert on that. Don't alert on how much CPU you're using. Use that CPU level to actually diagnose problems. So one way that's a good way to look at this is to start with those work metrics, figure out the underlying resource metrics, and then look for any events that cause changes. And so when we look at the resources, those resource metrics end up becoming work metrics for other teams, right? So from a high-level business perspective, the work metric is to ensure that your online store is operational and customers can check out. The resource then is that the web server is up and running. Well, that resource becomes a work metric for your web team. They're in charge of keeping your web server running. So then you can dive into the resource metrics that support that. Do they have the servers? And so on. And so you can start to drill down and start to find the technical causes of issues. So I gave you some good ideas of how to think about metrics, the qualities that you want. Let's use Datadog as an example. We use a lot of Postgres in our product, and we've scaled it really well. As I mentioned, we handle trillions of data points every day. So how do you scale Postgres? Well, I mean, this is one solution, right? You just more everything. You have a Postgres server, and I think a lot of people do this. You start off with one Postgres server. Your company starts to grow. What do? Well, you add more memory, more CPU. You make this thing as big as it can. That obviously doesn't scale very well, right? At some point, you can't buy 5 petabytes of RAM and shove it in one machine and all the storage in the world. So rather than scaling vertically, you can get more instances, right? You scale horizontally. And with some databases, things like Cassandra, NoSQL stuff that's designed to be distributed, this gets really, really easy. With Postgres, you have to be a little bit more intentional about it, right? Because if you're thinking Cassandra, it's eventually consistent. But I think a lot of us have chosen Postgres because it has strong consistency. So an obvious solution is this model. You have a single write master, receives all of the data it writes, and then it replicates to a bunch of read replicas. And so you can read from those. This has a lot of great benefits because Postgres has a ton of great optimizations built in. So it can dynamically optimize for what it's reading, and it can dynamically optimize for the writing. So you start to get these specialized servers. So when we were scaling Datadog, what were some of our requirements? Well, obviously, with this model that I just showed you, you want to ensure that your write master is writable, your read replicas are readable. That's a given. But you also want to make sure that those read replicas stay up to date, right? That they don't lag too far behind. Because if you're writing data to a master and you have a bunch of people reading off really stale data, that's a bad thing. And then additionally with that, you want to ensure that your read replicas can be provisioned quickly. So if you have a massive surge, you want to be able to grow your replica pool quickly. So how did we do it? Well, these two solutions, Postgres and Wally. So Postgres, as I mentioned, there's a bunch of great stuff that's been built into Postgres. For example, just having replicas. Replication in Postgres has gotten really, really good. Wally, on the other hand, it's a project that was started by Heroku. It's a really simple way to essentially back up and restore data. So Wally is the write-ahead log E. I don't know what the E actually stands for. I think it was just to make Wally. But there are 4 commands with Wally. You can do a backup fetch, backup push, or a wall fetch. So you can grab that write-ahead log, and a wall push, so you can push that. And one way that we use this is essentially allows us to back up and quickly restore. So every day we do a daily Wally backup, and we use that to provision our replicas. So it allows us to make replicas without those actually having to touch the write master. And so we can get them up to date to the day, and then getting them caught up to the specific time in the day ends up becoming really easy and a pretty small task. The other nice thing that this provides us is that when we have the backups, we're able to restore things. So, I mean, everybody knows that having backups is nice, but this really does allow us to restore backups really quickly, particularly if we have a customer that managed to delete all of their dashboards and they're like, what happened? How can I get it back? We can easily get those back for them. So our actual Postgres setup looks a little bit more like this. We've got our write master. We also have a bunch of standbys for that, just in case it goes down. You want to have something available that can quickly swap in and become your new write master. We also have multiple replica pools. And the reason that we do that is we have certain applications that read from certain pools. So it allows us to scale a little bit better. So that's some of our setup, but really we're here to talk about monitoring. So how do we monitor that kind of a setup? Well, we can start with what metrics we gather. These are all the different Postgres metrics that we gather. They're pretty standard. If you were to sign up for Datadog, you would get all these metrics as well. They're all pretty basic. We grab them out of PG Stats and a few other databases. They're all things that are available to you. And all of them are important in some way. You don't want to be gathering metrics that aren't important. So all of these are very useful for troubleshooting various things. And I'm sure if you could read those, it's pretty small, I know, but some of them would probably stand out to you as things that you actually monitor in your own systems. But let's dive deeper, talk a bit more about what we monitor, how we monitor, rather than the metrics. So I know that I said that you should alert on work metrics and then investigate with resource metrics. And again, I think that might have been a little confusing because if resource metrics become work metrics, then law of transitive properties, you're thinking that I mean to alert on everything. But really, it's about who gets alerted at each level. So if we start with thinking of those work metrics as the first level is the business, alerting your leadership when your company is losing money. And then turning those services that are supporting that, so your web applications and various services, those are really responsible with your developers, right? The people that built these systems. So they would receive the alerts whenever service goes down. And then you can drill down. So for us, this is where our Postgres team sits. Right behind the developers, Postgres engineers actually ensure that the Postgres servers are running, that they're up. And this is actually really our ops and SRE team. So if you have a large organization, this might be different from your sysadmins. For us, it's pretty much the same. So ops SRE not only covers the Postgres work metrics, but the resources that support those Postgres work metrics are also part of their secondary work metrics. So let's talk about Postgres work metrics. We have titled these availability. They're metrics that you want to ensure are there to keep everything running. So what are we alerting on? Well, we're alerting on if our base backup is too old, right? If your base backup is too old and you're not getting that backup out of Wally properly, then it's going to take a long time to spin up replicas. So that's one thing you want to alert on. Also, if standbys are missing. If you don't have a standby for that write master and it goes down, you're no longer writing. So keeping that around. And then the big one for us is if replication lag is too high. So again, ensuring that whatever people are reading doesn't trail too far behind that write master. As I mentioned, our team does both the server management and the Postgres, so those work metrics do become, or those resource metrics do become their work metrics, but those they've titled capacity. So on this, we are alerting more on those traditional resource metrics, things like connection limits. Are we saturating the pipes and people can't actually connect to Postgres? You want to be monitoring for things like disk, ensuring that you have disk and memory and CPU that are all available. Now, you've probably seen this, and this is the agile software loop. The idea that whatever you monitor should go back into the planning to create new features or to create new processes around your business. Well, one way that we like to think of this with that plan and code is to start thinking about performance. So let's talk about monitoring to improve your performance. Where do you get the most performance gains? So that link there is actually to a session that Josh Burkus gave at this conference, I believe, 2 years ago. Josh is just downstairs or a few doors down giving a different session. But he says that the 5 ways that you get the most performance gains is first to cut activity, right? If you're making queries that aren't doing anything, or you're querying for data that you already have in your code, then cutting those out is the biggest way to get a performance gain. Second is to look at slow queries. Third is to scale your stack. So we've already talked a little bit about scaling. Fourth is to fix your hardware, so get the right hardware that you need. And then fifth is to actually do the configurations. So I know a lot of us, when you're using Postgres, spend a lot of time tweaking the configurations to get it just right. When in actuality, cutting activity and dealing with slow queries is really where you should be spending most of your time. So let's talk about cutting activity. Cutting activity is hard. It takes work. At Datadog, we have an APM tool. There are a lot of APM tools out there. If you're using Datadog or New Relic or any of them, you should be able to have access to essentially looking at what queries you're running. So APM tools are really useful for that. But it's still a lot of manual work to figure out, are these things doing useful work and not just pulling redundant data that you already have. But one thing that APMs can really, really help you with is cutting down those slow queries. So you can filter on the average latency of a query to figure out which queries are slow. And a lot of people think about this as like, well, what difference does this do from the slow query log? Are people familiar with the slow query log in Postgres? That's not a lot of hands. OK, sidetracking here. Slow query log. In your Postgres configuration, you can enable it. Set a time, a minimum time. Anything that runs over that time, any query that runs over that time will get logged. So that's a really easy way to see what queries are running slowly in your Postgres. And then you can start to address those. But the problem with running just slow query log is that where do you set that threshold of what, whoa, fly. Where do you run that threshold of what do you consider a slow query? And there's a notion of, if it is a slow query, is it slow because it should be slow? Thinking of a giant financial query that is running over months and months of data, doing a ton of joins, versus something that's really small, right? If we define performance, is this top query of selecting from a small table on a non-indexed column, if that runs in 1 second, is that actually more performant than a larger query that has proper indexes but is doing a join and runs in 1.5 seconds? I like to think of things actually, rather than thinking of it in pure time as the slow query log does, thinking of it as potential versus actual speed. So one way I think of potential, particularly when you're looking at doing things with joins or sorts, is to start looking at RAM versus disk. RAM is always going to be faster than disk. So if you can do those things in memory, then you'll get better usage, better speed. You'll be fulfilling your potential. So if we look at when Postgres is actually using memory, I love this quote from Robert Haas. It was on linux.com, but essentially workmem is part of your configurations. Workmem allocates how much memory is available to a query to do things in memory, things like sorts, things like joins. And he says that raising this value can dramatically improve the performance of certain queries. Unfortunately, a lot of people go way overboard with this. They're like, all right, crank that number up. If it's at 32 megs, double that to 64, or double it again to 128. But it's important not to overdo it. You have to read his complete sentence. And the reason that it's important not to do it is it's a per connection memory. So the more connections you have, the more memory it'll eat very, very rapidly, and it can quickly crash your server. So rather than actually increasing it, our SRE team had this suspicion that in the same way that a goldfish will grow to fill any size of pool that you put it in, bad queries will grow to eat up as much memory as you allow them to. So rather than increasing workmem, how about decreasing it? So that's actually what we did. We decreased workmem, and then we started to monitor temp bytes. So this is our graph from temp bytes. Temp bytes is something that I encourage all of you to monitor. Temp bytes is essentially whenever Postgres has to write to disk. So temp bytes essentially shows us when it runs out of memory. Whenever it runs out of memory, then we get this on our chart so we can see that it's writing. And that either means that we've had a configuration change, and for some reason we are not allotting the memory that we should, or that the amount of data in our tables grew so large that we can no longer accomplish tasks in memory. Or often the case is that a query was added or changed in code that is now not efficient and that we can optimize. So once you start monitoring temp bytes, how do you actually find those queries that you can optimize? Well, you can use the explain analyze. Are people familiar with explain analyze? Great, I'm seeing many more hands. You should all be familiar with that. Explain analyze, for those who didn't raise their hands, is just a way that you can actually take a query, and rather than just running that query, for example, select star from table foo, you would write explain analyze select star from query foo. And Postgres will actually tell you its run plan, run the query, and then provide you statistics behind it. So how to use this with temp bytes? Well, you use this essentially you can manually do it whenever you see that temp bytes is being written in your monitoring solution. You can correlate that timestamp and go back and look in your slow query log. Or one thing that you can do is you can turn on auto-explain. Auto-explain is a module that's available in Postgres, and it will run explain analyze on anything in your slow query log. So rather than actually having to tie timestamps from what you're monitoring to what's in the log, because it automatically runs, then you can just search for essentially whenever it writes to disk. So you can search through that log, see what's writing to disk, and immediately see the query and the execution plan. Now, I should warn you that running auto-explain with explain analyze does have a pretty big overhead, so you don't want to do it all the time. But turn it on for when you're actually trying to optimize your system, or if you're monitoring for those temp bytes and you start seeing your system write a lot. Turn it on, gather some information, turn it back off, and then look through that information. So, in summary, monitoring Postgres really comes down to the basics of monitoring. Ensure that you have the 4 qualities of good metrics, that they're well understood, that they're sufficiently granular, they're tagged and filterable, and that they're long-lived. So you're getting people to understand the data, they're getting the accurate data, you can query against it, and you can start to recognize the patterns in your systems. And then the other parts of this, ensure that you're understanding the difference between your work metrics and your resource metrics and your events, and you're using those to drill down into your systems. And ensure that you alert on those appropriate metrics. And with that, that's time for questions. Unless I'm running low on time, but I don't think I am. Nope, cool. Any questions? Yes?
When you mentioned the BA outage cost $80 trillion, was that dollars?
That was dollars, I believe. Yeah.
Seems a little bit high. I mean, I think that's like 30 times the UK GDP.
Yeah, so that's essentially just multiplying the 5% loss times the number of shares. So it is sort of a made-up number of how much they lost in stock. But the real number was that they did have to pay out the $80 million of real hard cash to customers. So yeah, not particularly important to monitoring, only to underscore that when you have an outage, consider more than your outage takes away from your company, not only in revenue that it could gain during that time and loss in your time, but for a lot of us with what we work in, people that work in the financial industry or in regulated industries, there are significant penalties for when you have outages or when you have other issues. So monitoring quite important to avoid those. Yeah.
Jason, do you have you experienced any particular issues in doing multi-site monitoring as opposed to monitoring a single cluster?
Yeah, so the question is, have I seen any issues of monitoring multi-site versus single clusters? Really, that's one of the reasons that I think Datadog is great, but really anything where you can get sort of a centralized system. So ideally, with us, we encourage people to send all of their metrics up to us, and then you can see everything in one combined dashboard. If you are in an organization where you have multiple teams and everybody has their own dashboard, you always run that risk of someone says that something's out and you're monitoring other things, and from your perspective, things are fantastic. So if you can get everything into one system, and you can do that with, most monitoring systems work on the same basis that we do. You have an agent, it ships metrics to somewhere. So do your best to try to pull those into one centralized location. Yeah.
So earlier you mentioned about alerting on different levels, or so to speak. How do you get around, make sure you don't suffer from alert fatigue?
Yeah, so the question is, I've talked about the various levels of alerting, and the question is, how do you get around alert fatigue? So part of those levels, if I roll back in my slides here, is the notion that not all of those levels are the same teams, right? So you start with the leadership, and they're receiving your high-level stuff. So they should be able to use your monitoring tool to get alerts that matter to the business. Websites down, customers can't check out. There's a drastic change in online orders, things like that. And so those are the alerts that they would get, but that's all the alerts that they would get. They shouldn't be receiving alerts that a particular service is down. That's where you start rolling those alerts to developers, to the people that matter for that particular service and are responsible for that. And then when it comes down to your ops engineers, they shouldn't be receiving alerts that a service is down on a service level. They should be receiving alerts that whatever they're responsible for, whether that's the hardware or the specific portion of the application is down. So you should be limiting based on tiers and areas of concern for each level of those. And then other ways to reduce those alerts is to ensure that you have things like anomaly detection. So you can have machines start to filter out the noise. So machines can easily tell when, if you keep that history around, they can easily tell that this is a pattern. There's always going to be a spike because this cron job runs every weekend. So don't throw an alert versus when it's actually like a real thing.
So do you have an opinion on should an alert only be fired off or sent if it's an actionable alert?
Yeah, so the question is, should an alert only be sent if it's an actionable alert? And that is true, yes. If you're sending alerts that have no action, then why are you sending an alert, right? So largely when we have alerts, when people create automated notifications, not only should it say what went wrong, but I always encourage people to have an action plan within that. So in your alerts, when you're sending notifications, ensure that you have a link to the dashboard where someone can actually look at things. Have a link to a wiki page or some sort of document that says, if you're receiving this alert, it's because, CPU is high. If CPU is high, go to this dashboard and take a look at it. Also, follow these steps. Take a look at this service that's part of it. Take a look at anything, any correlating factors that you can. Give people the steps. And then also, more importantly than that, also give people a contact. There's always going to be that one person on your team who's primarily responsible for whatever that thing is. And they're usually going to be the domain expert. Have a link that has a way that they can contact that person just in case they need backup. Yep.
So when lower things in the stack, say a full SAN array goes down or a core network switch goes down, obviously everything above that is going to start blowing up and alerting too. Are there any ways within Datadog's platform to prevent that blow up of thousands of things coming at you?
Yeah, that's a great question. The question was, if you have something low level, like a SAN goes down or a network switch goes down, that obviously makes a service fail, so that sends alert, and the service fail makes the overall work metrics fail, so everybody gets alerts. So how do you prevent that? One way that we prevent that in Datadog is we have a thing called composite alerts. Composite alerts allow you to have separate alerts, so you have your work level alerts of like, the online store is down. You have your low level alerts like, the SAN can't be reached, like it's pinged, so we know it's down. Composite alerts allow you to combine those together and say that when action A happens and action B or not action B, and you can essentially use Booleans to tie together multiple automated alerts. So in that case, you could have it send an alert to just your network engineers when the network switch goes down, and not fire off the rest of those alerts. Yeah, so if you're doing automated notifications and monitoring, it is really helpful if you can find a system that allows you to start doing a little bit more complex logic of tying things together rather than simple logics of is something up or down. Yep. That's a great question. Any other questions? No? Thanks for coming. I know I guess we went a little bit short, but I'll be up here. I'm happy to answer questions. And then, as always, if you think of anything afterward, I am available. So get Bisect on Twitter if you're a Twitter person, or jason.ye@datadoghq.com. Always happy to answer your questions about monitoring in general and provide you with information, Datadog or not. So, thanks.